Here are the worked out solutions for the last practice worksheet that we're going to do before the quiz over gas law questions. I'm going to solve these questions using the four-step process that we've used recently in class. The first thing I suggest doing is to solve the word problems in the same way that you would approach a word problem on the SAT test. Read the question once to get a sense of what it's about. Then read the question again, and the second time you read it, identify any important information. Question 1. Calculate the mass of 15.0 liters of NH3 at 27 degrees Celsius and 900 millimeters of mercury. NH3 is ammonia. I'm going to assume it's ammonia gas because of the lesson that we're working on. It asks me to find the mass of the ammonia, so I'm already thinking I need to find an answer that's in grams. I noticed that it gave me a value that's liters, that's a volume. I noticed that it gave me 27 degrees Celsius, that's a temperature. And I noticed 900 millimeters of mercury, that's a pressure. So I've read the problem, and the sense that I have about it is that it's about a gas, and it's about volume and temperature and pressure. This is a gas law problem solved using one of our 5 formulas. Now I'm going to read through again. I'm going to identify all the important information and label variable quantities. It asks me to find the mass. It gives me this value and this value and this value. The mass is not represented by one of the variables in the gas law formula. However, we have recently found the mass of a substance by knowing how many moles there are. And then we can change from moles into mass. We just recently did that on the bell work. 15.0 liters is a volume. You have to know that liters measures volume. 27 degrees Celsius is a temperature. You've got to know that Celsius is referring to temperature. Also, when you use your gas law formulas, you can't have the answer in Celsius. It has to be in Kelvin. So you need to remember how to change it into Kelvin by adding 273. So the value of T is 300 Kelvin. And then finally, the 900 millimeters of mercury is a pressure. The reason that I labeled my variables without any subscripts, the little ones and the little twos, is because there is only one volume, there is only one temperature, there is only one pressure. So far, I've done step 1 of the 4 steps described in the instructions. I've identified the variable quantities. Now comes step 2, write the pertinent formula. We want to use our gas law formula that uses the variables V, T, and P. That's the ideal gas law, PIV-NERT. On the quiz, you get credit for simply writing out the correct formula to use. So we have done step 2 of the process. Step 3, show the substituted values. In place of P, put in the 900.0. In place of V, put in the 15.0. N is number of moles. That's not provided to us in the problem, so I'm going to leave the variable N. In place of R, the ideal gas constant, I'm given in the hint that it's 62.36. Sometimes the number you use for R is 8.31. Other times it's 0.0821. In this problem, it's 62.36 because the pressure was in millimeters of mercury. It wasn't in atmospheres or kilopascals. In place of T, let's put in our temperature, 300. That's step 3, showing the substituted values. Now step 4 is use the calculator to give the answer with the proper label. Here's where your algebra skills need to kick in. You need to make decisions. How will you get the variable alone on the side of the equals where you see the variable? Our variable is the n. We want to get that alone. we need to remove the 62.36 and remove the 300. Both of those numbers are being multiplied to the n, so they are removed using division. Divide by the 62.36 and divide by the 300. Your math teacher probably wants you to show that on both sides of the equation, but in chemistry class, the more important thing is that you're able to articulate what it is you need to do to get the variable alone. By dividing by 62.36, this number cross cancels. When you divide by 300, this number cancels, and you're left with the letter n. N equals an answer that you get on the calculator when you type in this math expression. This is going to have a combination of multiplying and dividing. Anything up in the top is multiplied, and then those two numbers in red ink are divided. The result is 0.7216 moles. Often we would be done with the question at this point. We found the answer for the variable n. But this question asked us to find the mass. So there's an additional step of work. We need to change moles into mass. Let's do that over here on the right. Write down the number of moles that you have. This gets your dimensional analysis started. Then write times and draw a line. Down in the bottom, we'll write 1 mole. And up in the top, we'll have the label grams. And there will be a number here that we get off the periodic table for the substance ammonia. Remember, we just recently practiced this on the bell work, so you would know how to do this. Ammonia has 1 N and 3 H's. So the weight of N was like 14.00 something on the periodic table, and the weight of the H was 1.0079. You need to take the weight of N and add the weight of 3 H's. That is 17.03. These labels will cross-cancel. The label that remains will be grams. So on the calculator, we have this last multiplication to do. The result is 12.3 grams. So I took you through question 1 step by step of how I would approach it. Now, you don't need to do things in exactly the same way that I do, but if you struggle on these word problems, then I strongly suggest that you tackle them in a step-by-step process. You're going to have a lot better chance of getting the right answer at the end. Here is question 2. First, read the entire question through. Get a sense of what it's all about. A volume of 26.5 milliliters of nitrogen gas was collected in a tube at a temperature of 17 degrees Celsius and a pressure of 737 millimeters of mercury. The next day, the volume of the nitrogen was 27.1 milliliters, and the barometer still reads 737 millimeters of mercury. What was the temperature on the second day? This talked about nitrogen gas, so it's about a gas. I noticed volumes mentioned, temperatures were mentioned, pressures were mentioned. This is a gas law problem. You're going to use one of your 5 formulas. Now read through it a second time and find all the important values. Here is a measurement. Here is a measurement. Here is a measurement. Here's another value. Here is another value mentioned. And then here comes the question, right? What is the temperature? Step 1 on the quiz, the first thing you get credit for is labeling variables for all of these quantities. 26.5 milliliters is a volume because milliliters is a measure of volume. And not only that, but we're even outright told the word volume. Later on, there's another mention of volume. And so we need to call this one volume number 1. The next number is the 17 degrees Celsius. Celsius is a measure of temperature. You need to know that Celsius is temperature. This one does give us the outright clue though, temperature. Temperature has to be in Kelvin. So 17 plus 273. That's 290 Kelvin. Reading a little bit further, we're given 737 millimeters of mercury. That's pressure number 1. Whoop, back here on the letter T, that's temperature number 1. I forgot my little subscript. The next number we get to is 27.1 milliliters, another volume, so V2. 737 millimeters of mercury, that's a pressure again, P2. Although I'm already noticing that both pressures are the same, the pressure did not actually change. Reading further, the question asked, what was the temperature? This is the second mention of temperature, so T2. That's the first step of the 4-step process. The next step is where you write down the formula that you're going to use for the problem. Now, I have labeled V's, T's, and P's, but I noticed that the pressure did not actually change. So I don't need to use the combined law. I only need to use the law that has the V's and the T's. Here it is. If you accidentally use the combined law, then you're going to put 737 in place of both the P1 and the P2, and you'll still get the right answer at the end. So that's not going to mess you up if you don't notice that you can use this simpler formula. The next step is to make substitutions. So in place of V1 is 26.5. In place of T1, 290. In place of V2, 27.1. And T2 is still the letters T2. That gets you credit on the quiz, just getting the numbers filled into the correct locations. Now the fourth and final step is where you solve this using your algebra skills. This equation looks like a proportion. There's a fraction on both sides of the equal. And the variable is in the denominator. So when you have this problem, the best way to solve this is probably with the technique called cross multiplication. You're going to multiply these two together and write down what it makes. 26.5 times the T2. You just write these next to each other. Then say equals. When you do cross multiplication, you're saying that two things are equal. You're saying that the diagonal products are equal. Now multiply this direction. 290 times 27.1. Cross multiplication takes an equation that uses fractions and it makes an equation that no longer has any fraction. Next, divide by 26.5 to get the T2 alone. If you divide by 26.5, then that's going to cross out and the T2 will be alone. On the calculator, we can see that we have to times the two numbers in red and then divide by the purple number. The answer is 297 Kelvin. Always remember that your final answer has to have some sort of label by it. You can't only just give a number like 297. You have to put some label. So you have to pay attention to what is the variable you're figuring out. We're figuring out a temperature. What's the label that you use for temperature when you're doing gas problems? We use Kelvin. Here's question 3. First, read the whole problem. Just pay attention to what it's about. Get a feeling for it. At a pressure of 405 kilopascals and a temperature of 200 Kelvin, the volume of a gas is 6.00 centimeters cubed. At what pressure will the new temperature and volume be 300 Kelvin and 4.00 centimeters cubed? I noticed the word gas was mentioned. I saw pressures, I saw temperatures, I saw volumes. This is a gas law problem. We're going to solve it with one of the 5 formulas. Now let's read through it again and find the values. And label those values. 405 kilopascals is a pressure. And I'm going to call it pressure 1 because later on there's another pressure given. 200 Kelvin is a temperature. I'm going to call it T1 because later on there's a second temperature. 6.00 centimeters cubed is a volume. The question asks us to find a pressure, so that's P2. That's the second mention of pressure. 300 Kelvin is a second temperature, and 4.00 centimeters cubed is a second volume. The next thing you do is you write out the pertinent math formula. This is the combined law, and it looks like this. I really hope that you've got your notebook ready to use on the quiz. Do you have all the laws written down? And do you know how to decide when something's a pressure and something's a volume and something's a temperature? Have you written down the extra notes to yourself so that you know what kPa goes with and you know what liters goes with? The next thing you do is you make your substitutions. 405, 6.00, 200, and now on the other side of the equals, the P2 remains as a variable, 4.00, and 300. Notice that the temperatures were already in Kelvin, so don't accidentally add 273 thinking you need to turn them into Kelvin. They're already in Kelvin. The final thing you have to do is solve this equation to get the variable to be alone. Now let's think about the algebra that would be involved. We need to get rid of the 300. The 300 is being divided under the P2. So if you multiply by 300, that removes the 300. Now how are you going to get rid of the 4.00? The 4.00 is being times after the P2. If you divide by it, that'll get rid of the 4.00. On the calculator, this is what you're typing in. Everything on the top, you times them. The two numbers that are under the lines, you divide by both of them. The result is 911. We need to give a label. Well, what were we asked to figure out? We were asked to find a pressure. Well, pressure can be done in atmospheres. Pressure can be done in kPa, kilopascals. Pressure can be millimeters of mercury. Which one do we use here? Well, in the problem, the other pressure was kPa, kilopascals. Question 4. Calculate the pressure in kilopascals of 0.421 moles of helium gas at 254 Kelvin when it occupies a volume of 3.32 liters. I noticed the word gas. I saw pressure, I saw moles, I saw a temperature given, and I saw volume. This is a gas law problem. Let's go through another time and find all the important information. We're going to have to find the pressure. Probably will have to use that number. I bet we have to use that number. And I bet we have to use that number. Pressure is P. There's not another pressure mentioned anywhere else in the problem. So I'm just going to call this P. I'm not going to call it P1 because later on there's nothing to be a P2. The next number, moles, is N. The 254 Kelvin is a temperature. And the last one, the one that's in liters, is a volume. Because liters is volume, and not only that, it just tells us the word volume. What formula uses P and N and T and V? It is the ideal gas law, Pivnert. On the quiz, you get points for labeling the variables in the problem, and you get more points for writing down the formula. The next step is to make the replacements. We don't know a number to put in for P. That's what it asks us to find, calculate the pressure. So you leave the variable P. Now in place of the V, 3.32. On the other side of the equals, the N is 0.421. The letter R gets filled in with a number. There's different numbers you use for R. Sometimes it's 8.31. Sometimes it's 0.0821. The number you use for R depends upon what the label was for pressure. We're told that our pressure is going to be in kilopascals. That's when you use 8.31 for R. So again, do you have your notebook ready for the quiz? Do you have the different values for R in your notebook with some kind of notes explaining when you use each number? Next, let's fill in T. The temperature is 254 Kelvin. All right, after you've filled in every single letter except for one of them, now figure out how will you solve it for that unknown letter. Find the missing letter. I see the P. I can see where the P is, right there. What's next to the P? There's a 3.32. That 3.32 is being times to the P. So to remove it, you use division. That gets the letter P alone. So on the calculator, multiply the three purple numbers together, then divide by the red number. The result is 268. What label do you use for the pressure? We're specifically told in the problem to use kilopascals. Question 5. At STP, a sample of gas occupies 24.5 milliliters. Calculate the volume of this gas at a pressure of 2.3 atmospheres and a temperature of 301 Kelvin. When I read that and thought about the words that I was saying, I noticed the word gas mentioned. I noticed a volume was given, the number that was in milliliters, that's a volume. I noticed there was a pressure. I even noticed temperature. This is a gas law problem. It's going to use one of the formulas. Okay, I'm going to read through another time and find all the important information. STP, that's telling me a certain temperature and a certain pressure. I bet we need this number. It says calculate the volume, so that's the thing we're going to find out. That's going to be where the variable is. We're going to need to use this number. We're going to need to use this number. Okay, standard temperature is outright telling us a temperature. Standard temperature is 273 Kelvin. Is there another temperature later on? There is, right? 301 Kelvin. So this one is T1, because later on there's another one that's going to be T2. Okay, STP tells you something else. It also tells you a pressure. So pressure number 1 is equal to a certain number. And in the hint, we're told 1 atmosphere. The 24.5 milliliters is a volume. Later on, it says calculate the volume. So that's a second mention of volume. It gives us another pressure, and it gives us another temperature. Okay, paying attention to what variables we've identified, I think we need the combined gas law. After you write out the formula, just copied straight out of your notebook, now fill the numbers into the correct locations. In place of P1 was the 1 atmosphere. In place of V1, 24.5. In place of temperature number 1, 273. In place of P2, 2.3. V2 remains as a variable. And T2 is 301. Now, study this equation that you've created. Find where the variable is. and think about how do you get that to be alone. You got to get rid of the 301 and you got to get rid of the 2.3. So we need to times by the 301 and then divide by the 2.3. This expression that I'm circling is what you type in the calculator to get the answer. Everything on the top, you multiply them. The two numbers that are under the bars, you divide by them. The result is 11.7. Now what label? Well, what were we finding? Were we finding a pressure? Were we finding a volume, a temperature? What were we finding? V2, a volume. Well, what label was used for the other volume? It was milliliters. And so this one is milliliters. Number 6, a 500.0 gram block of dry ice vaporizes to a gas at room temperature. Calculate the volume of gas produced at 25.0 degrees Celsius and standard pressure. I noticed the word gas was mentioned. I saw volumes, I saw a temperature, I saw the word pressure mentioned. This is a gas law problem. I'm going to go through another time and find all the things that I think are important. I bet we got to use the 500 grams in some way. We probably are going to need to know that the molar mass of carbon dioxide is this number here. We're asked to find the volume. We're going to have to find the V. Here's a temperature, and then we're told standard pressure. The 500.0 grams is a mass. Now, we don't have any gas law formulas that use mass. One of our gas law formulas did use moles, though, and we know how to turn mass into moles. We recently did it on Bellwork. When it asks us to find the volume, how about we call that one V? 25.0 degrees Celsius, that is a temperature, but we need that temperature to be in Kelvin, so you add 273, and that makes 298 Kelvin. Finally, it gave us the words standard pressure. Standard pressure is an actual number. In the hint, we see that the standard pressure is 101.3 kilopascals. Now pay attention to the things we've labeled. We labeled a V, we labeled a T, we labeled a pressure. Whoops, I forgot to say P right here. So that was a P right there. And we even know a mass. I'm thinking the ideal gas law. I'm thinking that with that mass given to us, we can find the number of moles, which means we can find the answer for N. Once we know the answer for N, then we could get the answer for V using the Pivnert formula. So step number 1, let's get the number of moles. Start by writing the 500.0 grams. Multiply and draw a fraction line. In the top, we want to change into moles, so you're putting the 1 mole in the top. Down in the bottom, put the 44.0 grams. These cross out, and we'll be left with moles. On a calculator, go 500 divided by 44. The result is 11.36 moles. That's the N. So now we can use Pivnert. In place of P, put the pressure, 101.3. For the V, leave it as the V. That's what we were asked to find. What is the volume? It asks us for that. In place of N, 11.36. In place of R, we're going to use the ideal gas constant. There's different numbers you put in for this, but in the hint we're told this time we use 8.31 because the pressure was in kilopascals. And then in place of T, 298. Now think about how to get the V alone. There's only one number next to the V. There's a 101.3 right in front of the V. How do you get rid of that? By dividing by it. That makes it cross out. Now the letter V is alone. On the calculator, you multiply the three purple numbers together and then divide by the red number. The result is 278. What label do you use? We're finding a volume. Should it be liters, milliliters? What do we use for volume? In the hint, we're told to use liters. Finally, problem 7. O2 gas in a canister with a volume of 40 liters at 25 degrees Celsius and 0.70 atmospheres is compressed to a volume and pressure of 32.5 liters and 1.4 atmospheres. At this new volume and pressure, what will the temperature of the gas be in degrees Celsius? This was about a gas. I saw volumes, I saw temperatures, I saw pressures. This is a gas law problem. You're going to use one of your 5 formulas. Going through it again, this is a number, here's a number, here's a number, here's another number, another number. Now it asks us a question. What will the temperature be in Celsius? Let's label our variables. 40 liters is the first volume mentioned. Later on, there's another volume mentioned. 25 degrees Celsius is the first temperature mentioned. Later on, the word temperature appears again. So T1 is equal to 25 plus 273, which is 298 Kelvin. The 0.70 atmospheres is pressure number 1. The 1.4 atmospheres mentioned later is the second pressure. Notice you've got to know that atmospheres measures pressure. If you don't know that, how are you supposed to get these right? You've got to have knowledge. If you don't have the knowledge in your head, then you've got to have it in your notebook. It asks us, what will the temperature be? That's T2. With all of these variables that I've identified, this is looking like the combined law. Writing the formula gets you credit on the quiz. Now fill in the numbers. Not just sticking the numbers any place I want to. You've got to put the numbers in the correct locations. Okay, now that we've created the equation, we need to figure out what sort of algebra is needed to solve it. The variable is in the bottom of the fraction. This has happened before. When the variable is in the bottom of the fraction, this is when you use the technique called cross multiply. Multiply this diagonal and write down what you get. You're going to get 0.70 times the 40 times the T2. And then that ends up being equal to the product of the other diagonal. 298 times the 1.4 times the 32.5. Again, the point of cross multiplying is it takes an equation that has fractions and it makes it into an equation that doesn't have any fractions. Next, think about how you can get that alone. Well, there's 2 numbers in front of it. Let's divide by both of those numbers. Divide by the 0.70 and divide by the 40. If you divide by those numbers, those cross out, and the T2 is alone. On the calculator, multiply the 3 red numbers together and then divide by both of the purple numbers. The result is 484 Kelvin. Now, typically you'd be done right there. You found an answer for the temperature, but this particular problem specifically asks us, give the answer in Celsius. On the quiz Friday, I'm not going to trick you like this, but there's no reason that we can't get it, right? To turn Kelvin into Celsius, subtract 273. And the result is 211 degrees Celsius. Okay, that was all 7 of the problems. I went through them really slow. I went through them step by step, and I tried to explain to you exactly what goes through my head when I see these hard word problems in a science class, or like even in a math class, right? Or even when you're doing the SAT test. Read the question through. Think about what you read. Like, try to make sense of it. Try to connect it to things you've learned in school. Then read through it again. Highlight, underline, circle, whatever you can do, all of the important values that you think are going to come into play when you're working out the problem. And then for these chemistry problems, pick your gas law formula from the 5 choices based upon what variables you identified. Substitute in all the numbers. There'll be one spot that still has a letter, and then use your algebra skills to get the answer for that variable. When you write that final answer, make sure you include a label by it. You cannot only just write a number, not in chemistry class. You always got to put some kind of label to say what it's measuring. Good luck on Friday's quiz. Make sure you've got your notebook ready to use.